Well, good afternoon. This is the end of a long conference. But we have a few speakers today. We're going to focus on the annual grass issue across the western USA. So I'm going to start and just do an introduction to the annual grass problem. Then Brian Mealer's going to talk about how you would recover from a situation where you have to try and reseed and reestablish plants into a totally degraded area. And then we have Vicky Maloney going to present the whole annual grass issue perspective from the Canadian point of view. And then Corey Ransom is going to talk about how you prevent annual grasses from totally devastating a site. You know, how can you control them? How can you prevent this degradation from occurring? And then Tim Prather's going to focus on the impacts of the annual grasses on fire. And then finally, Shannon will talk about all the ecosystem benefits that are achieved once you control the annual grasses, which basically tells you how devastating these annual grasses are to the whole ecosystem of western US rangeland. So I'm going to start with my introduction here. And just a general overview of the issue throughout the West. So, firstly, we have a lot of different annual invasive grasses. And it's actually quite interesting how many of them have managed to take a foothold. So there's a list of some of the most common ones, a lot of bromus species, Bromus tectorum or cheatgrass being the most common one. That's what you hear the most about. It often occurs in combination with some of those other bromus species. We have Bromus rubens, mainly in the drier areas in the southern West USA. Medusa head and ventonata are two that are spreading extremely rapidly. They're more devastating than the Bromus species because they have very little forage value. And then feral rye and also schismus, which is kind of in the Mojave, sort of the desert southwest, where it's causing really serious issues. So if we just take the example of the Great Basin, and I'll kind of put a yellow box around the proximate area of the Great Basin. So there's been some recent work done there. And then they looked at areas that had greater than 50% cheatgrass or Bromus tectorum infestation and minimal shrubs, and looked at the change over time. So the average rate of increase, 230,000 hectares per year, and this is from 2010 to 2020. So just over that 10-year period, increasing at the rate of 230,000 hectares a year. And so the devastated area now covers 7.7 million hectares, which is 20% of the Great Basin. And there's been an 8-fold increase between 1990 and 2000. And then over the last 30 years, the leading edge has been moving upslope by 138 to 459 meters. And that's dependent on the slope and the aspect, how much the annual grasses have moved up. And a lot of that upward movement is due to the changing climate. So overall, if we take all these annual grasses together, there's over 40 million hectares that are impacted. And I should say these are all invasive winter annual grasses. So germinate in the fall or winter, sometimes early spring, and then they have this very rapid growth in late winter. They steal all the nutrients and moisture before the native perennial populations really start to grow. And there are really severe consequences. All of these are documented many times in the literature, so lots of wildlife habitat, larger and more frequent wildfires, depleted forage for livestock production, disrupted hydrologic and nutrient cycles, reduced biodiversity, and degraded pollinator habitat. So I thought I would mainly sort of demonstrate this problem by showing pictures across the western USA, really moving from the east to the west. So the annual grasses really pick up in Wyoming, Montana, Wyoming, Colorado corridor, and then moving west from there. And so this is the High Plains ecoregion in Colorado with the Bromus tectorum infestation. And then I have the strip there where the Bromus tectorum has been controlled, just so you can see the impact of that annual grass in that area. This is from that same region, just another view showing the area with the annual grass, and then once it's been removed. And I should mention that the western US rangeland are composed predominantly of perennial species. So you get perennial forbs, perennial shrubs, and perennial grasses. And so these annual grasses just fill a niche that really is not filled by native species. So that's one of the reasons why they seem to be able to take hold very effectively. So this just shows a larger region in the northern Great Plains in Wyoming. You can see on the left-hand side the cheatgrass infestation, Bromus tectorum, and then what it looks like after that grass has been controlled. And the reason why it's green versus brown in all of these is because the annual grasses senesce very early, really in late spring. They start to die back and turn brown, and that's why everything looks brown, and if they're not there, it's green. So many people have actually forgotten what the US West used to look like. So we now have got used to looking at brown, where if you took the exotics out of the system, it would be green, would still be green. So this is Ventonata, also in the northern Great Plains of Wyoming. And then if we move a bit further west, this is like the intersection of the High Plains and the Southern Rockies. And you can see a strip has been sprayed along the road to remove the Bromus tectorum. And you can see how the impact of that annual grass just suppressing all those native forbs, shrubs, and grasses. And this is another species in that same area. This is what we call feral rye or cereal rye. It gets really tall. And to the right-hand side of the fence, you can see what it looks like if that grass is removed. So we often see this in areas where it looks like there is nothing left except the annual grasses. But once they're removed, we often find that there are a lot of native perennial species just waiting to be released. And they respond very nicely to the removal of those grasses. This is a picture in the Colorado Plateau. This is actually Dinosaur National Monument. And just covered up in cheatgrass. But you can see that white oval there shows a bit of green. Those are the perennial grasses. So you can tell from that, if that picture was taken without the annual grasses at that time of year, it would have been green. And then these annual grasses can invade even without fire. And we know there's no fire for a long time in this area because of the sagebrush that you can see, but the whole understory there is just totally dominated by Bromus tectorum. And then, of course, these annual grasses provide the fine fuel for wildfire. So we have the situation where naturally occurring wildfire may be every 50 or 100 years in these areas. And once you get the annual grass infestation, you can get wildfires as soon, in a much greater frequency, maybe as short as even 5 years. So just repeated wildfires because the annual grasses ignite extremely easily. And they also fill in all the natural space that could break the ability of a fire to spread, so you have this continuous fuel coverage. And so what you end up with is near monotypic stands of the annual grass, where a lot of the perennials now have been killed with the combination of the annual grass infestation combined with repeated fires. And this is a really bad situation now, because the only way to recover would be to go and reseed and replant these areas. And most of the West is extremely dry, arid. So replanting and reseeding is an extremely difficult thing to do and very expensive. And if we just think briefly on the impact on soils, what's going on, we're replacing this shallow-rooted monoculture of exotics, have replaced our deep-rooted, diverse, native system. So you can imagine that has really significant impacts on the soils. So we're going a little further west here. This is Middle Rockies in Montana, Bromus tectorum invading a greasewood shrub area. This is actually in Yellowstone National Park. And then in the Wasatch and Unitah Mountains in Utah, this is the different species Medusa head here you can see, and how competitive it is for those perennial grasses. But if you remove it, the perennial grasses are ready to respond and take off. The key is to make sure you do the treatments before you've degraded to the point where there's no perennials left to take over. And if you do get to that point, you have to do this reseeding. So this is a major fire area caused by cheatgrass or Bromus tectorum infestation, Snake River Plain in Utah, and this is the Birds of Prey National Conservation Area. And huge areas there that have been reseeded with this perennial grass. But it's clear that it'll take decades or probably generations for it ever to look like a diverse native perennial system again. And this is another example in that same area of a re-establishment attempt. Those are sagebrush planted in there, but all that grass you can see invading is the cheatgrass or Bromus tectorum coming back. So it just kind of highlights how difficult and expensive it is to re-establish vegetation on these sites. So we get into Central Basin and Range in Nevada. Nevada is really ground zero for some of the most devastated areas that we have. And you can see the infestation happening in there. Without the fire on the right-hand side, you see the annual grass area where the annual grasses have been removed. You do see a lot of bare ground where the annual grasses are removed. And that's a natural state because of how dry the West is. It's natural to have a lot of bare ground between the perennial grasses, forbs, and shrubs. And that's what the annual grass fills in. And here's another reseeding attempt, and again, you're faced with this issue of the reinvasion of the annual grasses. And if you control the annual grasses, you can see how the restored species do respond to that. So this is going into the Blue Mountains now in Oregon. This is Ventonata, so all that light color there, that's all the annual invasive grass, Ventonata dubia. And looking at it, just the whole scene, everything light in that picture is all Ventonata dubia infestation. And this is in the Zumwalt Prairie Preserve in northeast Oregon. And now we're getting into California, the Eastern Cascades, slopes and foothills. This is Medusa head infestation. So this is taken in summer when it's already senesced, which is why it's all brown. But on the right-hand side, you can see how it looks after you control that. This is a pretty devastated area. And then if we go to Southern California, this is in the Mojave Basin. We have the Mojave Desert, and these areas have no history of burning. The plants and animals are just not adapted at all to fire. So we have the Joshua tree, we have desert tortoise, which is endangered species. These are all devastated by the wildfires, and the wildfires occur because of that annual grass that's creating the fine fuel. So these areas seeing fire for the very first time. And that's a picture of what the Joshua trees can look like after a fire. There's very, very small percentage of them actually survive a fire, maybe 5 or 10%. So yeah, Joshua trees, people are very concerned that they actually are going to disappear in the future with climate change, with annual grass invasion, and with with those two, yeah, climate change and annual grass invasion. So I thought I'd just show you that pictorial tour, because the pictures are worth 1,000 words, and to just set the stage for the rest of the presentations. So with that, I could take a couple of questions. Yeah.
When did cheatgrass first invade?
Oh, so I can get some help here, but it was many decades ago. That Brian, do you know when? The question is, when did cheatgrass first invade? Late 1800s. Yeah, so it's been there a long, long time. But the problems got a lot worse recently. So, okay, we need to move on. I just looked at the time, so. So our next speaker is Brian Mealer with University of Wyoming. Oh yeah.
Thank you, Harry. I'm gonna try to watch my timer here and not run over too far. Harry gave us a really good overview, introduction. So I'm Brian Mealer. I'm faculty at University of Wyoming. I would like to make sure that I recognize Jody Crows, who was a PhD student of mine who did a lot of the research for the data part that I'm going to show. But mostly I'm going to talk about some principles that I think we are having to figure out a little bit more when moving into some of these areas that are so degraded that they need active restoration to take place. And just out of curiosity, how many of you work in improved pasture systems versus in natural systems? Okay, so some of the things that you're probably, oh yeah, no kidding, we already know that stuff, and we've known it for a long time, but the key for us is sort of translating that into natural systems and the complexity that comes along with those. So I'm going to use some data to illustrate some of those principles from some research that we've been doing, but I wanted to step back a little bit. Harry did a great job. I'm going to put a little bit more context around this. So some recent research using some global data, looked at intact grassland systems around the world, and kind of made the claim that there are about 7 highly intact grassland ecosystems that still remain, not from a vegetation quality perspective, but from a disturbance and contiguousness standpoint. You can see kind of where these are. I'm going to focus largely in this area. That's where I do my work. The Wyoming Basin portion of the sagebrush grasslands has been claimed to be one of the most contiguous remaining grasslands in the U.S., or in the world actually, one of the top 7. Another set of recent research also shows that sagebrush ecosystem is relatively imperiled, and I'm gonna illustrate that a little bit more. We look at the sagebrush conservation design from Doherty et al. Dark blue indicates sagebrush grassland ecosystems that have a high level of ecological integrity as determined by 5 factors: sagebrush cover, perennial grass cover, and then some negative factors, which are annual grasses, conifer encroachment, and human modification. So this would have been a snapshot from 2001. Dark blue is good, light blue is kind of semi-good, and then tan is not very good at all according to their measurements. And so if we look at a change over a 20-year period, the thing that really jumps out, I'll kind of go back and forth, is you see what the shift is. There is much less dark blue, much more light blue and tan. The interpretation from that is that over that 20-year period, roughly 1.3 million acres of sagebrush grasslands have degraded annually. And so the claim is that this system is actually highly imperiled, and 75% of that degradation over that time is attributed primarily to invasive annual grasses. All of the things that Harry showed clearly illustrate that the downstream ecosystem effects of these grasses are degrading a really large, important, and unique ecosystem for the United States at a relatively rapid rate. But we can do things. So Harry showed a bunch of pictures like this. Green in the foreground. Here's actually a treatment line. This is in northeast Wyoming. Everything that's largely this tan color back up beyond that treatment line is ventonata and Japanese brome and other invasive grass. Part of the discussion that we're having with this sagebrush conservation design team is not going to the worst, most degraded areas first and trying to restore them, but working in areas that maintain recovery potential and trying to minimize those impacts before we lose those other ecosystem functions and structures that we need for those productive ecosystems. So we talk in terms of defending the core and expanding the core habitat and preventing further degradation. So my first sort of key principle is the easiest way to do rangeland restoration is don't wait till you have to do rangeland restoration, is be more proactive and mitigate the problem before you get to that point. Unfortunately, and this is kind of a cherry-picked picture, unfortunately we get into some situations where we have very little recovery potential. And in these situations we are faced with the challenge of actively reestablishing desirable vegetation on sites that have been impacted by invasive annual grasses. For those of you that do this kind of thing, you know that we have a limited toolbox that we can work with when we're doing active restoration. And one of the tools that we currently have that is quickly becoming predominant is this relatively new herbicide called indaziflam, that is a root growth inhibitor that is not very mobile in the soil, and so it stays in a very shallow portion of the soil. And so as all of our annual grasses begin to germinate each fall, they are selectively reduced, while our perennials with roots below that herbicide layer are able to escape the herbicide and recover naturally. Can you see a potential challenge if you're using such a herbicide and you're reseeding native plants that have to be established at a relatively shallow seeding depth? I see some heads nodding, right? It might be tough because it is also active on those desirable species. So we got pretty interested in this, and we we started looking at a few different things. So one is plant material selection. Are there species that seem to show different levels of tolerance to this specific herbicide, indaziflam? We looked at timing of seeding relative to timing of herbicide application, and we looked at other things like depth of seeding. And I'm going to walk through some of those things in the next few minutes to kind of talk through what we've been learning. So Jody and I and a few others initiated basically a screening. I think we had 40-something different, primarily native species. This is one data slide, canopy cover, 2 years after seeding, and these were all seeded. At that point in time, it would have been 9 months following herbicide application. For quick interpretation, we broke things into 3 different categories. We had potentially tolerant to this herbicide, potentially susceptible, and then inconclusive. Inconclusive meaning that we just didn't get enough establishment, whether it was treated or not, to feel comfortable making some kind of a judgment call. And so if we look at western wheatgrass, for instance, the gray bars are the control, the non-treated. The blue are those that were seeded into areas that had been sprayed with indaziflam 9 months prior. We see that there's really no distinguishing difference between those two, so we would interpret that as being potentially tolerant or potentially useful in that situation. Others, we see really clear differences. We get on here to blue bunch, and those that were treated were the 95% confidence intervals overlapped 0, so technically not different from 0, and then the non-treated were much higher. We would consider those potentially susceptible. And then others where things all overlap 0, we just weren't comfortable making a choice. And what we were able to do over a few years is kind of develop an initial list of species that sort of fall into those different categories. And I'll show a couple pictures of this as well. So in some ways, not surprising, some of our workhorse western rangeland species showed some potential tolerance. Some of these others that particularly like to be seeded very shallow were definitely negatively impacted in that screening study. And then a heck of a lot more work that we have to do to kind of tease out some of these other species, whether they're going to be useful or not. I actually took this picture, I think it was 2 days ago. So this is a treatment line. So this is actually 4 years after herbicide application on this one site. You can see there's still a lot of cheatgrass located over here. This is a basin wild rye seeding here, and that was one of our species that clearly showed up as potentially tolerant. And you can see this tall statured bunchgrass in the treated area that was able to establish at nearly the same rate as was not in the area that was not treated. The challenge with some of this is that, especially with our species that are not very competitive, and many of our native species have not been bred or improved or selected to increase their early growth and competitive ability at an early growth stage, is that, as Harry suggested, the invasive annual grasses deplete that soil moisture early in the season, so our seedlings are not as well able to establish and compete during the establishment phase. Kind of that between growth stage conflict that we look at. So that made us really curious. So we got a list of species that were potentially able to tolerate this herbicide. And we also knew that it was tying up in the sort of shallow upper, we want to say ½ inch of the soil. It kind of depends on where we are. It probably depends on soil type. So we were curious if we could seed underneath this herbicide layer. It doesn't have foliar activity. It's only root active. And see if we could escape the herbicide by planting beneath it. And so Jody set up this really interesting greenhouse study where we planted seeds in soil in the greenhouse at different depths. Then we dosed them up with herbicide and we watched what happened. And so we have increasing planting depth going from left to right, and we have percent emergence on the y-axis for 4 different species. The gray highlighted area is the non-treated, and then the light gray is what was treated with indaziflam. And there's some really interesting patterns that we thought fit what our mental model was for what we would expect. So something like western wheatgrass, it established pretty well across the board at all depths without this herbicide. And then it was inhibited from establishment and emergence at shallower seeding depths, which fits with what we would think for the herbicide. Blue grama, we know that it only likes to be seeded at a shallow depth, and so it didn't do very well regardless of which depth we planted. It didn't escape. So you can see these different patterns varied depending on emergence requirements for those different species. Really cool. Fit exactly what we thought would need to happen. And then we moved this into the field, and a slightly different pattern showed up. So same scheme overall, but we're talking about plant density now. And what we saw was that in almost all of these cases, regardless of seeding depth, this herbicide reduced plant density when we seeded back into this. I want to put a very clear caveat on this, in that we completely violated all of the labeled recommendations because we were trying to push the limit of the herbicide to see if we could get it to work. So we for this particular trial, we seeded at those different depths, and then we sprayed the herbicide right the same day that we seeded. So we completely violated it. We were trying to see if we could get it to work. So I still think there's something to this depth issue, and we are continuing to do this work. But this is one of the key things, is that making sure that our weed management practice is compatible with our reestablishment practices and with the plant materials that we have. Right now, what we have actually shifted to with some of these programs is going with if we have to use a herbicide for establishment, is we're using a shorter residual herbicide. During the establishment phase, we get these plants established, and then we follow up with a longer residual, something like indaziflam, to let them continue to grow and flourish through time. I thought I had another, I'm going to skip and come back to that one. So part of that sort of sequential process was driven by this. I'm just going to show one picture of this. Like seedlings, the seed to seedling transition is the most vulnerable time for our plant species. And sagebrush in particular is a really weak competitor at the seedling stage. So to get away from that seedling emergence and establishment, we did some transplant work and then sprayed this herbicide, indaziflam, over the transplants. These are 2-year-old sagebrush transplants that were treated immediately after transplanting. There are also 2-year-old sagebrush transplants in here somewhere, and somewhere in here, and the survival was much lower, and you can't even see them when you get in there to walk around. And so it confirmed for us that if we can get something established and then reduce that competition over the longer term, then those plants are able to grow and establish and do better if we can get through that initial stage. Now I'm going to go back to this one, kind of out of order. We've been doing all this work in a couple different locations, and we were scratching our head, and we realized that we had a really good chrono sequence of time since herbicide application. So we had some sites that had never been treated with indaziflam. We had some that had been treated 1 year ago, 2 years ago, and 3 years ago. And so we went back in with these 6 species that had been included in previous studies, and then reseeded back into that, basically a replant interval study. And so all the way to the left for each of these species shows their plant density with no herbicide treatment. And although in some of these cases we're not seeing a statistical difference, the trend is that by the 3rd year after, for most of these, especially our cool seasons, we started to see an uptick in establishment in that 3rd year following treatment. 3 years is a long time to go after a herbicide application to try to reestablish some things, especially on slopes. But I think this is at least what the current label says 24 months, is that, or the stewardship guide says 24 months after. So I think depending on how you sort of cut that 3 years, we might be starting to see that is probably the right time window to get back in and do some reestablishment with this herbicide. I actually stayed at like 15 minutes, so I'm gonna just wrap up with this for a second. we're continuing to do a lot of work, not just us, but others, evaluating different populations of these desirable native species for their differential tolerance, not just to this herbicide, but to others. The key to long-term, I mean, there's multiple keys to long-term success with this, but if we can successfully deplete the seed bank of those annual grasses long enough to get long-term control and establish desirable perennial plants that can sort of capture that site and potentially reduce reinvasion into the future, then I think that's going to be more of a long-term solution than just coming back in every 3 or 4 years and spraying herbicides. I don't know that we're there yet. I will reiterate that working in areas that still maintain a high recovery potential is probably a much higher leverage opportunity than waiting until we have to come in and do active restoration. But I will say that I think we're probably closer now than we have been any time in the last, well, I don't know, maybe since the 1940s at being able to do this. And I say we're not going to give up. And so those are some of the principles that I think that we are trying to work through. And if we have time, maybe there could be questions that followed up from Harry. And then if you guys have questions for me, I could try to answer some as well. So thank you.
We have a few minutes for questions.
Or not.
You actually finished perfectly on time.
I was trying. I was watching my clock. Lockie.
There's a few minutes for questions.
So a question, I guess, probably for all the presenters. You guys have issues in regards to trying to get access to native seed. What's your ability to access native seed?
Yeah, so the native seed, well, I guess so the question was, I'm supposed to repeat the questions. You see that? The question was, do we have challenges getting access to native seed? And I would say yes and no. So the market is highly volatile depending on wildfire years. So big wildfire years, BLM buys all the native seed that's available. And then in other years, our seed producers that are growing and producing native seed have an excess, and so the demand is low and they have a hard time moving it. There is a pretty clearly articulated native seed strategy through a bunch of the federal agencies that's working to resolve that. And I will say that some states, so Nevada has a seed strategy. We are working on one in Wyoming. Idaho has one in place now too, to try to understand some of those dynamics and address those dynamics better. The NRCS Native Plant Materials Program for years and years did a great job developing different genotypes and varieties that were available, as you know, Lockie. But they've kind of shifted their focus due to some funding things, and they are not developing and selecting for native plant materials as frequently as they were. So yes and no. How's that? Great question. Man, back here.
Do you have a rough idea how long it takes to get the annual species seeds out of the seed bank? Are we talking years, decades?
Yeah, that's a great question. So if you look at published literature across the suite of species that Harry presented earlier, reports are anywhere from like 3 to 10 years seed viability, depending on the species. That, as you likely know, that's going to vary depending on soils and climate and things like that. Many of the landscape scale projects that are happening around the West right now are sort of hinging on that 3 to 7 year window, hoping that if we can have zero tolerance for seed production, we will deplete the seed bank. Great question. I don't know that we fully know that, but the data suggests that it's not like 100-year seed viability as it is for some broadleaf weeds. Great question, sir.
Just a comment and then a question. The comment is, in 40 years of looking at rangelands in New Zealand with Bromus tectorum or cheatgrass, we had the invasive phase, which Harry's just pointed to, and then over time, Bromus tectorum has dropped out, and it is far less than what it is without any intervention. That's the comment. The question is, have you got anything or seen anything similar in the US in your trends or research yet?
I mean, I guess I'm holding the mic. There are, and I can sure pass it off. Thank you for the comment. So the question was, have we seen any trends in a decline specifically with Bromus tectorum over time. We could talk for a long time about this one. But so there have been documented instances of mass die-offs in specific locations periodically. Sort of assumptions are it may be related to soil microbial communities and potentially an interaction with climate. Tim, are you going to talk about that at all? No. Okay. And I will also say, I don't know if you've ever read, maybe not, Lynn Kinter did her PhD at Washington State University like 2 decades ago now, and she compared genotypes for Bromus tectorum in the U.S., the western U.S., and Australia and New Zealand. And her work suggested that the genotypes that were present in Australia and New Zealand were less competitive and came from a different initial introduction than the multiple introductions that came into the western U.S. I don't know if that might be something that's related to it, but that's a really good question. And I don't know if anybody else wants to weigh in on it, but I think it's time for somebody else as well.
Yeah, and the general trend is that's continuing to expand and become a worse problem, but there are instances where, unrelated to disease, cheatgrass has diminished, but very, very isolated, kind of small examples of that. So our next speaker is Vicky Maloney. Vicky is with NView, and she's a development specialist for us up in Canada, and she's going to present the whole annual grass problem from the Canadian perspective.
All right, thanks, Harry. Yeah, like Harry mentioned, I'm going to talk kind of a similar kind of broad overview of the annual grass issue, but kind of more Canadian perspective and kind of zoom in on what's going on in Canadian rangelands currently today. Okay, so I'll start by giving a brief tour of Canadian grasslands, what type of grasslands do we have in Canada, where they're located, and a little bit about the species diversity that are within these Canadian grasslands. Then I will talk about what invasive grasses we have currently in Canada, finish off with some invaded ecosystem examples and strategies for protecting these Canadian rangelands. So a brief tour of Canadian rangelands. So if this is kind of an old picture that shows what used to be grassland in Canada. So natural grasslands originally covered about 61 million hectares of land, most of them being within the Canadian prairies here, that being Alberta, Saskatchewan, and Manitoba, but there's also substantial grassland ecosystems within British Columbia here, as well as if we go to the east in Ontario and Quebec. So that's what used to exist, 61 million hectares. Now, if we look at what is left of these grasslands and what is now cropland, you can see that a significant amount of those original grasslands within the prairie provinces has now been converted to cropland. As well as if we go to the east, looking at the Ontario tall grass prairies here, almost all of it is completely gone. It's all converted to cropland. And the grasslands that do still kind of exist here are farther up north. They're not nearly as productive. They're not really as great for cropland, and therefore have not been as converted to cropland. So just zooming in again a little bit more detail about the specific grasslands that we have, BC or British Columbia. We have these grasslands located in like the Kootenays of British Columbia. They're often very intermittently spaced within at the bottoms of mountains and valleys. It includes some of the largest remaining bunchgrass steppes left in Canada and provides habitat for a lot of endangered and threatened wildlife. So even though it covers less than 1% of the landmass in British Columbia, it contains 30% of all of the species at risk. It is located in that. And it's also very, very important winter habitat for mountain sheep, and I'll talk a little bit more about that when I talk about the invaded sites. Okay, then switching to the other side of the country, and I kind of already mentioned this, but Ontario's grasslands have been lost over the last 200 years. So originally there was an estimated 1 million square kilometers of tall grass prairie. Now there's less than 1% that actually remains. And within that tall grass prairie, you can see these are just small little remnants that exist. So there's no real continuous tall grass prairie that exist within Ontario anymore. Okay, and then switching to the prairies, this is where I currently live. I live here in Calgary, which is among the fescue prairie. There's 3 main types of grasslands that occur in the Canadian prairies. We have the tall grass prairies. Those were mostly in Manitoba here. Those are very, very productive ecosystems, high amount of precipitation, and because of that, very, very little of it is left. So it's mostly converted to cropland. Then in the in this area, in the mixed grass prairie, we have it's subject to frequent drought conditions, so it's not as good for cropland, but it's really good for, it supports a lot of livestock grazing. So that's where we have a lot of our pasture land and cattle industry. But over half of the remaining native grassland is in this mixed grass ecosystem. And then we have the fescue prairie ecosystem. It's a moisture environment in the mixed grass, and because it's moisture, it's a little bit more productive, and that's that strip down that we see here down leading to Montana. There's also the aspen parkland, and within the aspen parkland, it's just, there's different grass types within the aspen parkland, but what defines the aspen parkland is just that it's a transitional zone that occurs when the grasses are gradually declining and we're getting trees. But again, 90% of that aspen parkland is either farmed or developed. This just kind of reiterates what I was already saying. This is an older map from 2013 where it was already showing 25% of the native grasslands that remain, and you can see those spots there in the green versus all of what this original grassland ecosystem was. And this was 10 years ago, so it's even more now. So species diversity, I don't really have to go into much detail. We all know that grasslands, even though, a lot of people will see a grassland and they think, oh, it's just a monoculture of grass, it can't be that diverse. We all know that it actually is very, very diverse. And in Canada overall, in all of the ecosystems, we have about 80,000 species. That includes, insects and mites and all of that. So majority, over half of them, of course, are insects and spiders and that sort of thing. But we have 200 mammal species, 460 bird species, 40 amphibians, 40 reptiles, 1,200 fish. And there's about 300 of these that are found exclusively in Canada, nowhere else in the world. 800 are considered at risk, and of those 800, 60 of them depend exclusively on grasslands, so at risk of being lost. And these include species like the burrowing owl, the swift fox, the northern leopard frog, the black-footed ferret, and the prairie rattlesnake, and the peregrine falcon. So very, very iconic, beautiful species that are at risk because of the disappearing grasslands. So again, I really don't need to go into much detail about what's causing the loss of Canadian grasslands. It's similar all over the world. Fragmentation, of course, things like rights-of-way, oil and gas exploration, developments, and expansion. The big one, especially in Canada, of course, is the conversion to cropland, but we also have woody plant expansion, wildflowers, things that are also brought on by climate change, and then kind of the focus here is the invasive species introduction. So while we have invasive annual grasses, a lot of other issues that we have are with the broadleaf species, that being species like spotted knapweed, Canada thistle, swallowworts, sweet clovers, and a big one, a leafy spurge. But I'm going to focus kind of on the annual grasses since that's the focus of this session. So what are the current annual grasses that we have in Canada? So there's five main ones. There's the downy brome that we heard about, the ventonata, Japanese brome. There's other brome species as well, but those are the 3 big ones. We also have feral rye and jointed goat grass. But the big one, of course, is downy brome and ventonata. So I'll just talk briefly about those. So up until 2017, we thought we did not have ventonata. It's kind of like Medusa head. Harry talked about Medusa head. We currently have not had any reports of Medusa head in Canada, but from the trend that's going on, it's probably just a matter of time until we do. So in 2017, there was a site reported in Metro Vancouver, so in the city of Vancouver, but it was eradicated, so it's gone. 2018, there was another one in Grand Forks. It was considered contained. 2019, 3 more spots were reported, and then fast forward to 2023, and there's more than 55 sites reported. And that's just reported. And our reporting system in Canada, especially for species such as grass and ventonata that are not that obvious to the novice, person walking on a hike, they'll notice like leafy spurge or tall buttercup. Those sort of things are very obvious, whereas an invasive grass is really not as obvious and not as easy to report. So there's a lot more reporting that needs to be done. And this is from the recent reporting system. We can see that there's only a few different locations where ventonata has been reported, and only in British Columbia. We have not had any reports in Alberta, but it doesn't mean that it's not there. It just means that we haven't had it reported. But downy brome is by far the worst invasive annual grass, and it's spreading really, really quickly across Canada. So it's been present in Canada, same as in the US and in North America, since the late 1800s, and it's spread to all Canadian provinces except for Newfoundland. It has not been reported in Newfoundland. In BC, the sites are limited to regions of the Western Central Kootenays, the boundary area, Metro Vancouver and Nanaimo. In Alberta, it's mostly in southern Alberta, but it's spreading rapidly. It's also found in the Great Lakes of North and Northeast, so occurring from Ontario all the way to New Brunswick. But again, this is from a recent map reporting system from the Canadian Agricultural Partnership. They do a distribution of all regulated weeds in Alberta, so this is the most recent one. This is all of the different locations that downy brome has been detected or reported. So in this case, we have a little bit of a better reporting system in Alberta, but it's still really, really far from complete in understanding the actual extent of downy brome within Canadian rangelands. Some examples of invaded ecosystems in Canadian rangelands. So one of them is the Waterton Parkfront. So I don't know if any of you know about Waterton Park or the Waterton Parkfront area. It is part of the Crown of the Continent World Heritage Site. So in addition to Glacier National Park in Montana, it's part of the same ecosystem. And it's often considered one of the most beautiful places in Canada. Taking a drive down from around Pincher Creek in Alberta all the way down to the coast not to the coast, to the border, is one of the most beautiful drives you can do. And if you look here at this picture here, all of the mountains here are part of the national park. This is the Aspen Parkland that is at the base of the mountain. It is located outside of the park, and it's mostly privately owned ranch land. There has been places within the park where bison have been reintroduced, where they originally roamed, and they've been reintroduced to the park, and they're doing really, really well. And it's really quite cool to go into those locations and see that. There's also things like moose and a lot of other wildlife that are supported by this ecosystem. So what happened? 2017, there was a fire that was caused by a lightning strike that burned over 35,000 hectares, which included thousands of hectares of that native rangeland that surrounds the park. And you can see here the devastation of that fire. And even to this day, if you go to the park, it's still beautiful. A lot of the forest has started to come back, but it's very, very obvious the devastation that the fire left. And it burned the native rangeland as well that surrounded the park. And what resulted from this wildfire is almost complete monocultures of downy brome. That was once this beautiful fescue native rangeland has now become this monoculture of downy brome. So even though it didn't look like it was there before the fire, obviously was there, and it came back even stronger. And I've been working closely with the Nature Conservancy of Canada on some restoration techniques and what we can do to control the annual grasses here. And Lindsay Davison, who is the natural area manager for the Waterton Park Front, has said that downy brome it's successfully invaded a lot of critical landscapes, and it's really affecting conservation organizations like ourselves, as well as the landowners in that area, the private ranchers that own that land. Because, like Harry mentioned, Bromus tectorum is not a great forage for cattle. They'll eat it early in the year because it comes up so early, but they really don't prefer it, and it senesces very early. And this isn't going to change. The wildfires are getting more and more frequent, right? So this is just an example from Alberta. Currently, there are 87 active wildfires burning in Alberta right now, and we've had 466 already this year. Considering that most of this year has been winter, that's a huge number of wildfires. Last year there was 182 at this time. So that's more than in the last 5 years, the more we've seen in any second week of May. When I was leaving here to come, the air quality in Calgary was a 10 plus because it was just raining ashes. It's just, Alberta is on fire right now. So this increase in wildfires, of course, is going to lead to increases in annual grasses. Just a quick second example, a BC example. Some of that intermittent grassland that I described is a really, really critical habitat for bighorn sheep. So within the last 70 years, 50% of this habitat for the bighorn sheep has been reduced. And there's other reasons, of course, that it's been reduced, like the expansion on vineyards that have been put into that area. But invasive species are also really, really important, or have been really invasive and really devastating to this bighorn sheep winter habitat. And a lot of the broadleaves that they have there, they have had good herbicide applications, and it has worked to a certain extent, but right now, we currently in Canada do not have a solution for invasive annual grasses in these natural habitats. So the strategies that we do have, they include things like, I'll just go through this quickly, running out of time. So, mowing, other herbicides, grazing, fire, but these aren't actually solutions. These are just things that you've tried to do, but if you remove it manually, you're not doing anything about that seed bank. You're also, might be increasing the ability for other invasive species to come in, and it's only really a temporary fix. And a lot of these options are very, very labor expensive, and they provide these short-term benefits. So indaziflam that we heard talked about a little bit is registered in Canada, but it's only currently registered for industrial uses on railroads and that sort of thing, not for range and pasture. So we do have it submitted to the PMRA to be able to add range and pasture to that, to the Esplanade label, which is the indaziflam product that we have in Canada. And we have done trials within Canada to show that it will work, and we saw lots of pictures from Harry about how it will work in controlling these invasive annual grasses. So we're hoping by 2025 that it will be registered for use in range and pasture. And Brian talked a little bit about this, protecting the core thing, and I think we're really at that place in Canada where we don't have the huge degraded sites quite yet. We're getting there, like I showed you with the Waterton Park Front, but we really need to work in this proactive space, and that's where we are. And so hopefully we can get, organizations, conservation organizations, and then of course private land ranchers, those sort of people on board to understand the importance of controlling these invasive annual grasses so we don't get into this very, very degraded site where we're working in a more reactive state. So key takeaways, grasslands, Canadian grasslands. They're important. They're being degraded. Annual grasses are one of many issues, but still needs to be addressed. We need to act now before the problem gets worse. Thanks.
Time for maybe one quick question for Vicky.
Yeah.
How important under Grassland for the Canadian government? Because if you don't have a policy nationwide, it seems very difficult to do anything.
Oh, okay, the question was, how important are grasslands to the Canadian government? And a lot of our native pasture, our grasslands are crown land. So it's very important to the government to restore these. When we talk about carbon sequestration and carbon fixing within these grasslands, again, that is a huge issue for the Canadian government, one that they want to be, yeah.
How much funds the government is giving you available to do anything about this problem?
I don't know personally of any funds that have come from the Canadian government to, yeah.
Okay, thank you, Vicky. Okay, our next speaker today is Corey Ransom with Utah State University, and he's going to talk to us about how we prevent these areas from becoming totally degraded.
Thanks, Harry. It's good to be with you this afternoon and talk about weed management. I am a weed scientist and very passionate about weed control in various settings, including those in this rangeland type setting that we're talking about today. As has already been mentioned, we have many of the species that have been previously discussed across Utah, and with the diversity that we have in the state of both rainfall patterns, elevation, and latitude from north to south, we tend to have a gradient of different species depending on specific climates and habitats. Today I want to just talk about kind of how we got to this focus on preventing or protecting sites from invasive annual grass invasions. And I think any good weed scientists know that the very first principle of weed management is prevention. Prevention is always the cheapest way to control weeds, but it's often hard to get people to spend money on prevention because it's based on preventing something that may or may not happen in the future. I think what you've seen today is that invasive annual grasses, we don't have to wonder if treating them early prevents something. I think we have plenty of data now to show that the impacts of these invasive annual grasses really dictate or demand that we manage them earlier in the invasion cycle. And so this is something I kind of put together a while back, just thinking about when we go to do a treatment, the outcomes of that treatment depend on lots of things, including what the site looked like in the beginning, what desirable species are there, how long that site's been invaded, what the invasive species on that site are. And then we come in with our intervention, a lot of times a herbicide treatment, and then we have to take that into consideration. Does it do a good job of controlling the invasive annual grass? Does it have negative effects on some of the existing perennial vegetation on the site? How long does it provide control? All of these things are heavily modified by the environmental conditions. And so we have some really harsh environmental conditions in Utah. We have areas that have an annual precip of 100 to 500 millimeters of precipitation. So you can imagine when I get to the restoration part, why you wouldn't want to roll the dice unless you have to on restoration, given the possibility of getting way below the sufficient levels of rainfall. And then we take all these into a package, and hopefully the choices that we've made in how to manage that site are going to result in some positive things. But we've also seen where we can have negative impacts by doing management without kind of long-term planning and foresight. So here's a site. This is on Antelope Island out in the Great Salt Lake. And I think we would all agree this looks like a positive change. And basically what we've done is we've removed the invasive annual grass, cheatgrass in this case, from in between those perennial bunch grasses. And so this again has that open space that would be required for those perennial plants to remain healthy given the limited moisture that they receive each year. Here's another site where we successfully removed Medusa head, and now we have a thriving community of field bindweed. And, you know, I'm not sure this is a positive change, although the grower said his cattle will eat field bindweed, they don't eat Medusa head. So back to that idea of what is your objective in your management plan. So just focusing for a minute on the tools that we have that we've traditionally used. Glyphosate in its many formulations, used either non-selectively or really low rates or at different timings more selectively. Plateau or Imazapic and Rimsulfuron being some of the most commonly used, and then more recently what you've heard a lot about today in Dazaflam. And really we have this scale from no residual control at all with glyphosate to what we know to be fairly extended control with something like Indaziflam. And so again, as we think about management, we have to think about where do these tools fit in our strategy. And then let's just look at environment for a minute. This shows the cover, the percent cover of downy brome and perennial grasses on 2 sites within Dinosaur National Monument over the years from 2010 to 2015, so a 5-year period in untreated plots, so no treatment at all. And what you'll notice in 2012, it was dry enough in the monument that we basically had no downy brome or cheatgrass cover. So if you'd done a study in 2011, you would have found that it didn't matter what management, right? Because in 2012, there really wasn't any downy brome or cheatgrass. That's the importance of this environmental driver. That also, I think, is the importance of kind of looking at longer term research when we're talking about restoration or preserving particular habitats. And then I want to just show you really quickly, these same 2 sites, now we have downy brome and perennial grass response to a single intervention or a single herbicide treatment. So here we came in the fall and applied Imazapic. And you can see we drove that downy brome population down at Echo Park because we have higher moisture there. We got a little bit of a uptick in the perennial grass. And that what you notice is that within a few years, once moisture comes back and once the effects of the herbicide are gone, it kind of returns to its pre-treatment state. So that's not really sustainable to go in and treat just to get a 1 or a 2 year response and then have it return back to where it began. We even did one where we then came in as it was starting to return and we added some additional treatments. So this one has 4 total interventions. And I put this up here just to show you that Josie's Ranch, which had kind of a lower original grass cover and warm season grasses, it kind of did the same thing even with 4 interventions. Once you quit treating, it goes back to that original state. Whereas at Echo Park, where we had a much higher perennial grass presence, we see that these multiple interactions kind of started to stabilize that perennial grass community and allow it to remain at a higher state. But again, this is a lot of intervention going on to these sites. And these are just some pictures to show. You can see this is at Josie's Ranch, and you can see the impact of that invasive annual grass utilizing the resources. And then how green the grass looks when you remove it. This one, we removed the annual grass, but we also, the treatment here caused quite a bit of injury to the desirable grasses. So again, you have to take that into account in your management. Site where we didn't injure the grasses. And then this is at the Echo Park, and really interesting because you can see the sea of cheatgrass, and then you can see these treatment plots within that. And they all look pretty good until you get down close and you realize, oh, that one's green because this is sump poverty weed. So we did remove the invasive annual grass, but we converted it over to a broadleaf species that if you're grazing animals isn't really good for forage. So just the importance of carefully selecting the herbicides that you're using on a site, depending on what those management objectives are. Challenges with restoration. We have done some seeding trials over the past 5 years, and you can see there that out of 5 years of planting in the fall, we've had 2 where we've successfully established, a third where we got some establishment, but then the plants died by early summer because of drought. And again, this is moisture driven, and what we find in our environment is if you don't control invasive annual grasses at the time you seed, it will fail whether you have adequate moisture or not. Those invasive annual grasses will use up all that moisture and your seeding will fail at the very start. And this is just to show one of those years. You can see we had 4 inches below the 30-year average of precipitation, so that was a failure. And then the next year, we had 4 inches above the 30-year average of precipitation, and we got success that year. So as soon as my climate colleagues can figure out how to tell me what the precipitation will be next winter, restoration will become a really effective approach. So really, I think as everybody's talked about, this importance of managing these infestations as early as possible while we still have remaining desirable vegetation on these sites. And so starting in 2015 with some opportunity to work with Indaziflam, we've put trials out on the brome species and Medusa head as well as ventinata. And this is a really busy graph, but it shows some different treatments in untreated, rimsulfuron alone, glyphosate alone, and then combinations of those two with Indaziflam. Our initial cover started here at about 30%. The year after treatment, you can see all of the treatments really drove that annual grass population down to near 0. But by the second year after treatment, the glyphosate and the rimsulfuron are no different from the untreated. And you can see it just really follows the untreated through time. And the treatments that contained Indaziflam have maintained that well over 6 years now at near 0 invasive annual grass cover. I didn't have time to add it to the chart, but here's the untreated this past year, and here is the rimsulfuron plus Indaziflam. So still, even at 7 years after, we're seeing very low levels of those invasive annual grasses. Now you'd like to say every time you remove the invasive annual grass, you get this big bump in perennial grass cover, right? But that's not true because the big driver is the environment, and in this case, the precipitation. But we do see instances where these treatments that are providing that good long-term suppression of the invasive annual grasses are allowing those perennial grasses to produce more cover and, more importantly, more biomass. So here's an untreated Japanese and downy Rome infested plot. And then here's one just 2 years after treatment where we've controlled that annual grass. Literally looks like you fertilized the plot because it has more access to moisture, more access to the nutrients on the site. And then in a paper that we're trying to pull together right now, this would be averaged across all of the years of the trials, just looking at annual perennial grass and annual grass biomass. And you can see here, again, anything that has Indaziflam has given us long-term control, and we generally see where that long-term control is resulting in 2 to 5-fold increase in biomass of those perennial grasses over the lives of the study. So I would say that's a pretty good economic return for a grower who is trying to feed animals those perennial grasses. And then this is our site, our Medusa head. So you can see an untreated on the left and treated on the right. And the same kind of thing. We do see a little bit of that Medusa head coming back, a little bit of biomass accumulation over time, but still exceptionally good. And then wherever we're controlling that Medusa head with a little higher rainfall area for this trial, we see again really large gains in perennial grass biomass. And then I always say, if I want to know if I'm making a difference in the world, I just have to go to Google Earth. And if I can see my plots from Google Earth, then I must be making a difference. And so all this light area is the Medusa head infestations, and all of these brown areas are areas where we've removed the Medusa head and the perennial grasses have been able to grow. Ventonata removed, so a lot of plant diversity coming as well. And then this is a site that we treated that had only about 20% cheatgrass cover. So one of the challenges with these invasive annual grasses is at the onset of invasion, they're just filling in the extra space in between plants, and it might give the illusion that they're not really having an impact on the plant community. But again, if we allow them to continue to take that resource, we'll see that change from diversity perennial plants to that annual plant community. And so this is really kind of the paradigm shift, is how do we get people to treat while all of the species are present in enough abundance that we can take those invasive annual grasses out and prevent the conversion of that plant community to invasive annual grass dominated systems. And I think that's probably the take home message. So here's how I kind of put it all together. It's this idea, is there a remnant perennial grass or perennial desirable perennial community present? And if yes, then what can I do to protect that community from further degradation? If not, then we have to go through this process that Brian talked about. What are our different restoration options? And then once we do have some good restored species on that community, I think we still have to come back and talk about then how do we protect that investment of seeding and restoration into the future from reinvasion by these annual grasses. And I'd just like to thank those who have funded our research over the years. And if there's time, I'd be happy to field a question or two.
Yeah, we have a few minutes for questions.
Yes? Yeah, so a really great question. There's no naive questions, right? There's no bad questions. Do we have any annual grasses that are native to our systems? And as far as I'm aware of in our sagebrush steppe, we don't have many, if any, annual grasses. We might have some annual broadleaf species, and so those, have been raised as a concern by some individuals. If we're using a pre-emergent herbicide, what are we doing to maybe some rare native annual broadleaf species? But the challenge that we have is once it becomes dominated by invasive annual grasses, any annual species are not thriving, right? They're not producing seed. And so again, we have to come up with some kind of management. And we think through time, if we can get rid of the seed bank, that those native annuals probably have a lot longer seed life than our invasive annual grasses. And so once we remove that competition, maybe we'll actually open up opportunity for those native annual species to be able to come back. So, but again, long-term processes, but thanks for that question. Yeah.
One question I think that lady asked before, are you actually looking at the changes in the soil seed bank with those invasive species in those long-term policies?
Yeah, so the question was, are we actually looking at the seed bank in these long-term plots? And we have not, except for the fact that we go back every year and we're still not seeing. And pretty positive the herbicide's been gone for years. And so we just think that in some of our research sites that the plots have been stable enough, not animal traffic or anything, that with route reinvasion, we're not getting plants coming back from the seed bank. So we think, at least in these settings, the treatment outlasted at least the majority of the seed bank. And that's why we're just seeing this extended control 6 and 7 years after treatment, which is amazing. Well, thank you very much. Appreciate your attention.
Thank you, Corey. Okay. Okay, our next speaker today is Tim Prather. Tim is from University of Idaho, and he's going to cover the connection between annual invasive grasses and wildfires.
All right, thank you, Harry. So I am going to speak about some of the complexity that we have in our system and some of the ways in which we're approaching that. So to start that whole process off, taking a look at a number of different impacts, and that would be within these sage step systems, we're seeing a shorter fire return interval, and so that means that we're getting more fires. Our dominant sagebrush species are ones that don't become sexually mature until they're about 8 years old. They only have a 1.5 year seed life, and so if you get a fire within that time period, then you basically have that out of the system. So we're seeing a conversion to annual grasslands quite frequently within that sage step system. And with that, then we have a reduction in both plant and animal diversity that goes along with that conversion to annual grasses. In addition, then, we of course will have a loss of forage, and some of that loss of forage, when we're looking at both public and private grazing ground, that loss of forage may be a single year on the private ground, but when you go to the public lands, there's policies in place that would say that you have to stay out of those lands for at least an additional year and sometimes 2 years. And so you're out of that grazing opportunity for a couple of years. If it burns again, which happens sometimes in our area, then you've got someone that has no access to their public grazing lands for 5 to 7 years at a time. So that really then limits our economic viability. And so when you take a look at all these interacting issues, there's some really complex problems associated with that. One of the ways that we might try to deal with that is there's a lot of effort looking at adaptive grazing management, and there are inroads at agencies to help us to be able to adapt to situations and changes in whether it's changes in climate or just changes in variability year to year, to be able to adjust how things are grazed. So when we look at control of these annual grasses, there are some efforts to look at targeted grazing of those areas. We have herbicides, and then we also have what are called fuel breaks, and I'll mention those. It'll be pretty brief on that, but it's another tool that we have. Then when we look at these herbicide applications, then what are the impacts of those? And looking at plant community change, animal diversity, we're just starting to work in this area, so we don't have a lot of, we don't have data to go over with that right now, but we will in the coming years. So this is just a snapshot of what the sagebrush steppe looks like. And if you want to take a look at the area that I'm going to be talking about, it's this little area right here. There was an area that was in that protect the core, and that's an area that I'm working in. When you look at these other areas right through here, those are areas that are highly at risk. When we look at resilience of sagebrush communities. These would be the least resilient. These are in the drier areas, Wyoming big sagebrush. And as you move up, you get greater resilience. You go from warm to dry to cold and moist. And so the area that we're working in is really in this mountain big sagebrush area. So we're in that protect the core area, and so that's what I'm going to be talking about today. So low resilience to high resilience. And what we have is we have a number of grasses then as you go from drier to wetter, and you look at those resilience graphs, we have a complement of annual grasses that fit across all of those. So no matter what system you're in, we've got an annual grass for you. Aren't you lucky? So the work that I'm going to be talking about is in this wetter, and it's at the Rinker Rock Creek Ranch, which is one that the University of Idaho has. It's 11,000 acres of deeded ground and 11,000 acres of BLM and Department of Land's grazing allotments. One of the studies that we did, when you take a look at the scope of the problem, you need to be looking at addressing the problem at the scale at which it's a problem. And so one of the ways that we're going to be looking at this is through aerial application of herbicides. And so we undertook a study to look at this. And so this is an area that was treated with fixed wing, an area that was treated with helicopter. And there are, we approached this originally as a series of different amounts of water as a carrier along with the herbicide. The herbicide indaziflam, which is the main herbicide that we're looking at here, it's not very mobile in soil, and so if you don't have good distribution of droplets on the ground, then you have areas where you don't get control. And so we undertook this right in this particular pasture. One of the things I'll just say as a side note is this is also a pasture in which we have some leks and some pretty good sage grouse habitat, and that is one of the species that's used as kind of a barometer for how good these systems are functioning. Our pre-treatment data showed that we had about 55% annual grass within these sagebrush grasslands. So what we did is we then said, okay, well, we're not going to look at just whether it's 2.5 gallons per acre or 5 gallons per acre, 7 or 10. Let's look at the distribution of droplets, and we had water-sensitive paper that allowed us to do that. And so what we were able to do is look at actual herbicide droplet coverage instead of a gallonage. And so what we found is that when you had very low droplet coverage, what we saw was in some instances we got 100% control of the grasses. In other cases we got virtually nothing. So what it's showing us is that if we don't get good droplet distribution, we have a high variability in control. And as we move across this, in terms of droplet coverage, we're now seeing that we are increasing the droplet coverage, and now we consistently have very good control. So one of the things that we were able to look at is if we looked at herbicide droplet coverage and response from a couple of our perennial grasses, we had to separate out sandberg bluegrass because one of our treatments we had indaziflam alone, then we had it with imazapic, and what we found was that the imazapic could actually injure some of the sandberg bluegrass, and so we needed to look at those separately. And so if you take a look at herbicide droplet coverage in sandberg bluegrass, you can see here that we don't see much of a response. It's a slight upward curve. But if it's indaziflam alone, you can see that we have a pretty good response. And when we look at all the other perennial grasses, we're seeing that as the droplet coverage increases, we have better response in our perennial grasses. And what that's showing us is that we're being released from competition by those annual grasses. If we take a look at annual grass control, treated versus untreated, you can see here that what we're looking at here is the response of the perennial grasses. And this is just to give you an idea of what an untreated versus a treated plot looks like. So if we look at perennial grass response, from the year of treatment to 2021 to 2022, you can see that our treated are going up. We had a decrease in the untreated. This is a very, very dry year this year. And then they both responded. So we're getting response as moisture came back into that system. Whether we had annual grasses or not, those perennial grasses were doing better. Oops. So the other thing that I needed to mention is that when we take a look at the perennial grasses here, and we look at the forb cover, what we see, and this is in 2022, when we saw this increase here, we're seeing that our native perennial forb cover has done really well compared to the untreated. So we are seeing a response with the indaziflam and our perennial forb cover. And this was one of the areas of concern, is how would we impact those perennial forbs, and it looks like they're actually responding, as are the perennial grasses. If we take a look at the cover in the untreated versus the treated, 32 months after treatment, here's in the treated, it's 6% cover of cheatgrass, 41% in the untreated. And when we take a look at recruitment, so we looked at very small individual forb species, what we found was that we had equal recruitment whether or not it was in the untreated or the treated. So the annual grasses were not stopping recruitment, but neither was indaziflam. So this is, I guess this would be fairly consistent with what you're seeing too. So we are getting recruitment, and it's a broad range of species. We have, this is very diverse, about 72 different plant species out there. And we have 30 to 40 different forb species that we keep track of as we're collecting our data. And you can see there's some that are pretty charismatic. These little guys are a showstopper. You actually stopped the truck and went to look at them. They're just so beautiful. So one of the things that we found in this part of the study, that is with herbicide application, it does help with recovery of native plants. We had good grass control, and our diversity of our forbs were maintained, and we're getting recruitment from the seed bank. And so this is a situation where we have a lot of native plants, and so we can look at that recruitment. Anybody notice the animal in the picture? So this is a sage grouse chick right here. And we found that a number of our forbs, about 22 of our forb species, are ones that sage grouse prefer, the sage grouse chicks. So I want to, we are continuing to do some additional work. This was for fire. This is a sampling scheme for fire, and this is what one of our plots looks like. But what I wanted to do is to show you high shrub, high perennial grass. I want to show you 4 different situations, and then you'll see why I'm showing you these here in a minute. High shrub, low perennial grass. We can get high shrub to the point where we don't have a lot of other things, and so that is a problem as well. Low shrub, high perennial grass, and then low shrub, low perennial grass. So when we treat across all those systems, then what we see is that even with high shrub, high perennial grass, we're actually getting pretty good control. This is treated and this is untreated, and you can see that we actually had greater variability when we got to the low shrub, low perennial, and some overlap here. So these are overlapping in their treatments. So in that 1 year after treatment, the only one that shows a statistical difference is this one. And then when you go more years after that, then those differences show up. But this is just to show you that we are able to control them even in the high shrub. This is a little bit confusing, but we have shrubs here. Here are our higher shrub, our lower shrub, perennial grasses, showing up here, perennial forbs, and then annual grasses, annual forbs. And what I wanted to do was to show you how we convert this into a metric for looking at resilience. So if we take a look at creating a shrub index and a herbaceous invadedness index, so here's your invasive index and your shrub index. what we did is we took a look at our different plant communities, and what we find is that all of our plant communities are on this lower end of the invasive index, except for that low shrub, low perennial grass. So in that instance, that is invadable. And so that seems to be some good news, but that's not all good news. We're also doing some work on fire and looking at annual grasses and perennial grasses. We put them in these tubes, and then we have a chamber. We have thermocouples in here, and then we ignite this and see how they burn at different moisture levels. And what we find is when we take a look at things like, there's just different metrics, maximum temperature. Here's cheatgrass. As we increase fuel moisture from 5% to 45 or 55% fuel moisture, you can see that you decline in maximum temperature for all the species, cheatgrass and then 2 perennials, which is a Columbia needlegrass and blue bunch wheatgrass. They both decline. And when you look at consumption, virtually across the board, consumption is very high, even at high percent fuel moisture for the annual grasses. And you can see that here it drops down. So we're not seeing all the consumption of all those. So what we find is that when we take a look at, this is the effect size. So if this was 0 all the way across, it would mean that adding our cheatgrass doesn't affect the outcome. So if it's above this, then that means that the cheatgrass is causing more of a problem than if it wasn't there. And we see with the needlegrass, in terms of the sustainability of the fire, the duration of the fire, we're seeing that with needlegrass, it has a big impact. So needlegrass is more susceptible in the presence of annual grasses. Blue bunch, only when you get up at a higher mass. And so we have 20 grams of the perennial grass in all cases, and here's 10 additional grams of annual grass. And consumption, you can see that it's high consumption here, lower consumption here. So blue bunch seems like it's a little bit more tolerant in the presence of the annual grasses. So that's part of this story that says that even though we have this resilient system, these annual grasses are still going to be a threat because of that metric that we've been able to develop. So I just wanted to briefly mention some of the fuel breaks that we're looking at. This is what a fuel break looks like. It's about 600 meters across, and that's so that you can fight the fires from that. And we're looking at the possibility of considerable acreage being added. About 22,000 miles of fuel breaks might be developed. And we're going to have to look at management within those fuel breaks to maintain them at a lower fuel level. And so one of the treatments is, this is all a fuel break, just on 2 different sides of the fence. This has been grazed, this hasn't. Does that look like a fuel break? No. So that's one of the challenges that we have. So we're kind of trying to develop ways in which to deal with that. Here's an example of a fire. This is a military range that things go boom and they start fires. So here's a fire that came across. It was stopped initially at this right here. And then it broke through, and then it was stopped here. And then there was another fuel break out here that's not shown here, and it was stopped at that one. So these fuel breaks can work. It delays the fire. It doesn't mean that they're necessarily going to go out. But we have to be sure that they're functioning properly in order for us to be able to stop those fires. And so these annual grass herbicides are going to be important for that. So when we look at conclusions then, and Desiflam does allow us to look at native plant recruitment, and that even small amounts of cheatgrass increases flammability of perennial grasses. And so we're going to have to look at treating areas that are intact. And I think that's been mentioned here as well, but I think we've got more meat to the bone on that in terms of why that's important. Because we can get preheating of those grasses and then they catch fire and carry a fire. And that we're seeing that these fuel breaks can be effective, but we have to look at maintenance, and so that's going to be one of the areas that we look to next. And that is it for me, and here's a beautiful sunset from Rock Creek Ranch. But do you have any questions? It's time for one question, maybe?
One question.
Yes.
I wanted to ask from before, what about grazing all these controlled cheatgrass? What's the play that, how we place it?
So where do we place grazing within this control? So the areas that we're working in are grazed on a rotational program, and you look at utilization levels. So you try to stay anywhere from 30 to 50% utilization levels. It's much more difficult when you get in the rangelands to assess utilization, but you try to look at a lower utilization rate so that those grasses can recover. But yeah, that's a good question. Anything else? All right, appreciate your time.
Thank you, Tim. Well, last but definitely not least, we have Shannon Clark. Shannon is with Enview, also a development specialist, and Shannon's going to talk to us about all the ecological benefits of controlling the annual grasses.
Okay. Thanks, Harry. Okay, so I'm going to bring it on home from all those talks that we just heard. So I'm going to focus on what happens when we actually successfully remove annual grasses from the system. What do we see in terms of ecosystem benefits? So Harry kind of covered this, so I won't spend too much time here. But when we do get these annual grass invasions, we see things like decreased wildlife habitat, decreased biodiversity, decreased pollinator habitat. So I'm going to cover all those topics, and when you actually remove the annual grasses, what do you see coming back in terms of those ecosystem functions? Vicki showed this before. I knew she was going to show it, but I wanted to include it because I think it's a really good figure to talk about our proactive to reactive approach. And oftentimes we've been in this reactive phase, and we really want to get over here in the proactive phase. And so that's what my talk is really focused on, is what, when we are kind of maybe in this middle phase here, the benefits we can see that we wouldn't necessarily see if we wait till this reactive phase. So everything I'm going to show is annual grasses that were managed in this transition zone. So they weren't intact. They definitely had good levels of infestation, but they weren't completely a degraded state where we did have that remnant plant community to respond. And that's what's really critical, because what I'm going to show is really cool, exciting results, but it won't happen if you wait till this degraded state level. You won't see benefits like this. It will take a lot more effort to see those benefits. So I'm going to start out with looking at the the biodiversity response we see with treatments when we manage these annual grasses. And so this is a long-term study that's been going on in Boulder County, Colorado. I'll just flip to the methods here. You saw this picture earlier. Harry showed without all this stuff on top of it, just the strip that was treated here. But these are actually being utilized. What's really cool is that Boulder County is they're a county in Colorado. They're managing weeds. They have a lot of open space and natural areas that they own. But with that, they're also collecting data. So although they're not necessarily maybe scientists like we're all considered, I mean, they're doing work like that. They have people that know plant species. They have ecologists on staff, weed scientists, things like that. And so they're collecting a lot of really useful data. So one of the things they're doing is taking these large-scale treatments, and they're doing these belt diversity transects that we're calling, where they take a 4.5 meter swath width on either side of where the treated area kind of adjoins a non-treated cheatgrass infested area. And then they do get species richness, which is simply just presence and absence of species, a visual estimate of cheatgrass control, and then they've been doing some geospatial referencing data, which I'll show at the end. So they've utilized 12 sites for this data collection. And if you look here, all these sites occur within either a rare plant area, which is marked by purple here on the map, or an area that's considered imperiled or vulnerable area for plant species within Boulder County. So these are the 12 sites. There's a lot going on here, but I just wanted to show the application dates. So these sites range from anywhere where they were treated at the end of 2016 to the beginning of 2019. So anywhere from 4 to 6 seasons after treatment. Over here, we have a Colorado Natural Heritage Program significance rating. All but one site is a B1 rating, which is considered a globally rare and irreplaceable site due to the plant species composition that's on the site. These are determined using the Natural Heritage ranking methodology, and this Colorado Natural Heritage Program ranks these sites, areas across, these ecosystems across Colorado. The cheatgrass control in 2022, so just this last season when they evaluated, ranged from 95 to 100%. So basically, I just wanted to show the cheatgrass has been removed nearly all from the system. So to start off, this is just looking at species richness. So this is just those belt transects again and looking at what species were present. This is just number of species. So we go from 2019 to 2022. The check is in these dark boxes, and then the treated sites appear in the purple boxes. And you can see that step up over time of how many species they're capturing in these evaluations, up to 112 species this past summer in 2022. So they're observing more species in these treated areas as time goes on from removal of that cheatgrass. When we look at rare species richness, so these are the 6 rare species they're tracking. They have some significant ratings, considered globally vulnerable or uncommon at least. And again, these are ranked by the Colorado Natural Heritage Program. So they might not be rare in another area, some of these species, but they are considered rare in Boulder County. And some are considered rare across the Western US or across the globe. And they see, when you look at this is just number of rare species they're finding at each site. You can see that check stays relatively static throughout these years of observation, but you can see an increase in number of rare species they're actually capturing in the treated areas, which is really exciting and basically showing us that the impact that these annual grasses are having on rare species, and by removing them, we can actually start to see some of these come back into a site. And then this was kind of a cool, some cool information they put together with using the data that they're looking at with this presence absence data of what is cheatgrass doing to these species. So first you have this cheatgrass tolerant species. And so these would be native species that are present in over 80% of the cheatgrass invaded plots. So when we look at those check plots, what species are we seeing still present in those that are native? And what we found was that there's 0 of those rare species occurring in over 80% of the plots, only 2 short-lived species consistently occurring, and 17 forb species. When we look at highly susceptible species, we see that they're absent in over 80% of the cheatgrass invaded plots. So out of those 12 plots, they're absent in over 80% of them. All 6 rare species, there's 24 short-lived species that were not captured in over 80% of the plots, and 65 forb species. So in total, in the treated plots, what we had was 6 rare, 28 short-lived, and 105 forb species. I think it was just a really good way to show the impact that cheatgrass is having on these species and in what it's doing. And so when we talk about restoration and the need to restore in that transition zone or before it even reaches that degraded state, this is why. Serious impacts to biodiversity. This is the georeferencing data that I was mentioning, and so this is just showing one site, but what they're doing is with these rare plant species, they really wanted to capture the spread of them over the course of years and what's happening with them. And so at this site, in 2020, these are all the marks of rare plant species, nothing even appearing in the check site, and then 2021, you can see the expansion of rare species. This is the treated site here. And so they were tracking these 5 rare species at this particular site. And so you can see in 2021, they had 5 rare species in the treated area, only 2 present in the cheatgrass invaded site. they tracked 1,071 individual rare plants in that treated area and only 21 individual plants in the cheatgrass invaded site. So again, I think this, you can visualize the impacts cheatgrass is having to these ecosystems in the West when you look at data like these. And then, so moving on from biodiversity into pollinators, and this is actually just insects in general, we used several of these, actually the sites they were tracking these plant biodiversity information on, and we used it to track pollinator observations. And so what we did, we had 2 sampling periods, 2018 and 2020, so 1.5 to 3.5 years after treatment. And so each site consisted of a cheatgrass invaded area paired with a treated area where there was no cheatgrass present. And then weekly observations occurred throughout that summer time period. We made use of a kind of a belt transect method again to track pollinator or insect visitation to floral resources. And then we looked at flowering forbs. So this is from the 2018 sampling period. And so over here, we'll start here on the left with species composition. This is tracking each week, so there was 9 weeks of observations, how many species of forbs were flowering within the site, within the plot. And so the blue dot is the treated plot and the red dot is the non-treated cheatgrass invaded area. And so you can see every single week that blue dot is higher, meaning there were more species of flowering forbs within the treated area, more species flowering basically. Showing that impact because cheatgrass does make use of so much of the moisture we get, which in the West is very little moisture. It makes it akin to like being in a constant state of drought for these perennial native plants. And so oftentimes when they're invaded by cheatgrass, one of the first things they stop is reproduction and flowering. And so you'll see less flowering. And so that's why we see that response there. Then we look over here at Shannon's diversity index. This is broken down by site, but there was a significant increase in Shannon's diversity score across all the sites within the treated plots. And this is just looking at plant species composition. Now we'll flip to so that we had to kind of change some sampling metrics. So 2020 was a little bit different, so we can track insect and pollinator visitation better. And so this is when we utilize those belt transects to look at all the flowering forbs within a meter of that transect, and any insect that was contacting the reproductive structure of a flowering forb was recorded to look at basically visitation of insects. And so I have it separated. These are all the groupings we have of those arthropods, and then I have the group of pollinators here in the box. And so, because we looked at everything, but you can see the asterisk marks a significant difference in visitation to flowering forbs along that transect. And so the purple bar is the treated plot. So we see a lot higher visitation in those treated areas of arthropods. Then when we looked at just floral visitor richness, so the different species we were seeing out there of arthropods, we see again, so a mid-season assessment, late season assessment, a lot higher species were found in the treated plots higher number of species found in the treated plots compared to the non-treated plots. So basically saying, in conclusion of all of this, that pollinators and arthropods in general are making use of those treated plots more than they're making use of the control plots. And why? Probably because there's more floral resources for them to make use of in those treated areas. So then the last section we'll move into is the impact that cheatgrass is having on mule deer. So we're going from arthropods, little tiny insects, to big mule deer browsing species, but cheatgrass actually has a very large impact on mule deer populations across the West. A lot of that is because these sites are transitioning to winter annual monocultures, and through fire we're taking out a lot of these critical shrub species that they use, especially that they use for winter browse. But also, again, cheatgrass does use that moisture that those shrubs would make use of. Even though they're very deep rooted, it still has an impact in their growth and what browse is available. So sampling design was set up to look at this across 3 sites. And then this is again the Colorado Front Range. So Denver's down here. This is Boulder County. This red area is considered critical winter range habitat for mule deer. 3 sites set up. Again, they're all paired plots. So a treated area, a cheatgrass infested area. Within those plots, we had 61-meter transects run. And then along those transects, 20 shrubs were selected randomly, and the longest leader growth was determined on that each shrub. And that measurement was recorded. And so it's a lot of measuring, and the leader growth is the new growth that shrub puts on each year. And so then at the end, we can get an average, leader growth measurement in the treated versus the non-treated. There were several different shrub species. They didn't occur at every site, but they occurred at least at 2 sites. And then to go along with this, we had game cameras that were placed to track mule deer visitation into the sites. That's just an example of a site. So there's the treated area with the paired check. So this is looking at leader growth. And so you have leader length here. And so from 2018 to 2021, so 4 years worth of data, you can see it stays actually pretty consistent. And the light gray bars are the treated plots. The black is the check plots. So you can see there's a significant increase in leader length found on the shrubs within those treated sites. So this was just really crazy to us, because when you think about cheatgrass using critical moisture out of the environment, you don't think it would impact such a deep-rooted species like a shrub as much, but it is impacting the growth that these shrubs are putting on, and therefore the browse available in the winter range for these mule deer to use. That's just a picture, so of some of the longest leaders, the treated versus non-treated on these different shrub species we were looking at. And then lastly, just the game camera visitation. So we had those cameras set up in each of the plots in the treated and non-treated areas. This is looking from October of 2021 to March of 2023. And it's by month here, looking at the winter months. And so you can see in several of these winter months, this is the dashed line is the treated plots. You had higher visitation of mule deer within those plots, so utilizing those plots for browse compared to the non-treated plots. And on cameras detected on average 63% of days with mule deer in the treated plots, compared to only 25% of days where they were in the cheatgrass invaded plots. So kind of a cool way to look at what cheatgrass is actually doing to these larger animals like mule deer, and how it impacts even the overall wildlife habitat in these sites. Oh, I don't know what happened there. Okay, so just to wrap it all up, and I guess the session, since I'm the last speaker, kind of the conclusion here is that long-term cheatgrass or annual grass control, all the examples I showed were cheatgrass, but this goes for all the annual grasses that we talked about today, is really key to achieving these benefits and treating in that transition zone before we get to that degraded state. In the past, we've struggled to get this long-term control, and with some new tools available, we're able to achieve this 2+ years, 3 to 6 years of control where we deplete that seed bank, so we can avoid that conversion to annual grasses, and then we see those benefits to the wildlife habitat, the pollinator habitat, the forage biomass, and the native plant reestablishment. So with that, I'll take any questions. Yeah.
So on your treated versus your untreated, when you're looking at the mule deer, were those?
Yes.
Those were side by side. Is that right?
The treated versus untreated, when we're looking at the mule deer, were they side by side? Yeah, the plots.
Okay.
Yes. Yeah.
Okay. So it wouldn't be a matter of they don't have cover, so they wouldn't come to one versus another. It's really the shrub.
Yes, yeah. So the plots were all very close together intentionally. Actually, even some of them were sprayed for this purpose. If this ever goes back, yeah, where they're really they're adjacent to each other. Yeah. Any other questions for me or any other speaker that went today as we wrap up the session? Yes.
Question in general. We know that when you get cheatgrass, you increase your fire regime, which means you also get a huge amount of soil erosion and therefore loss in soil fertility. With any of the restoration, are you looking at ameliorating any of those declines in soil fertility? Is there fertilisation used to try just to compensate the fact you've lost a lot of your soil nutrients?
Yeah. Here, I'll repeat the question for the recording, but yeah, as the cheatgrass invades and you get fire, you reduce some of that soil fertility, and are we looking at adding any of that back in as we do restoration?
So one of the challenges we have is those fires now have gotten to be where there are hundreds of thousands of acres. And so when you get to that scale, it's really hard to be thinking in terms of dealing with those types of issues. So yeah, it's a matter of scale. But no, that's a really good point. And one of the things that often happens after fires, we do get a little bit of a surge of nitrogen availability. So that's a benefit.
Okay. Oh, yes.
Is there any thought about eradication of some of these invasive species?
That's a great question. Is there any thought about eradication in some of these? And I would say yes, at a local level. So where like Brian and I are at in northeastern Wyoming, we had Ventinata Medusa head move in, discovered 6 years ago, maybe 2016, I'll say, however many years ago that was. And we did take an EDRR approach to try to eradicate those species. Ventinata was found, it's just rapidly spreading through that ecosystem, so eradication is not possible on that one. But Medusa head, we are still in that eradication approach, and so any new infestations of Medusa head are treated and managed that way. So I think locally, yes, there are, across the western US, no, we're not going to eradicate annual grasses, but locally there are a lot of efforts in different regions to eradicate when they get new species coming in of annual grasses. Yeah.
I have a bit of a different question. So we saw now a lot of very local approaches. Do you have issues or are there programs that are throughout the United States, or are you only tackling those things on a local scale? And yeah, do you think that's a problem maybe?
Yeah. So I'll repeat the question. I think I'm going to give it to Brian because he's leading this effort. About are these just local approaches, or how do we deal with this on a large scale, landscape scale approach, because it is a issue that affects the whole western U.S. And Brian has a lot of experience with this.
Yeah, I don't know that I'm leading it. I might be involuntarily sucked into it. So I guess clarifying question, are you thinking more about from a detection, reporting, surveillance standpoint, or from a collaborative management standpoint?
Maybe everything.
Yeah, and so maybe everything. It's a great question. I think there are increasing efforts to coordinate across the entire western U.S. for this issue. Some of the sort of contextual stuff that I gave at the beginning of my presentation has led to more discussions in the past 2 years with a lot of the federal land management agencies. So if you get into a lot of the western states, more than 50% of the land is owned by the federal government. And so they have a very a strong emphasis on what happens in those states. And so a number of those organizations are pulling together with private landowners, with other partners, with universities, with other agencies to try to develop a more cohesive spatial strategy across the West. And that we've talked about this defend and grow the core strategy. That's very modular. And then if you own a piece of land, you can find core and kind of approach it from that perspective. But the intent is to think more broadly and have the agencies approach it from a more cooperative, cross-jurisdictional landscape approach. And I think that there are current trends in federal funding and other funding that will encourage those projects to be done. We've got a multi-state cooperative group working now that's looking at how to increase that cooperation. And so I think the scale of the problem almost dictates that we have to work at those levels. I just think we're still figuring out how to best do that. So I think that's a great question. Corey's going to jump in.
Just on a state-to-state level, one of the defining characteristics would be how widespread is that infestation. So like Ventonata, we still think we have less than 1,000 acres in Utah. So of course it's a high priority species. State funding is going towards trying to eradicate that species in the state, whereas Idaho or Washington has much more widespread Ventonata, and so that it wouldn't have the same focus. For us, we have maybe 10,000 acres of Medusa head, so that one's a little lower down our list. But of course, in Wyoming, they think they just have some isolated infestation. So there continues, even with the grow the core, there continues to be kind of localized priorities based on total distribution of the different species.
Great question.
Yeah. Any other?
Yeah, I'm wondering if there is any other treatment than just herbicides. I was surprised that the only, it seems, maybe I'm wrong, but it seems from the presentation that the only one tool that you use are the herbicides. And since the problem is so big, I don't feel like you will apply herbicide all over the Western.
Yeah.
So maybe that's something missing from the presentation.
Great comment, and just record it. Aren't there other things we could do besides spray herbicides? Some colleagues and I reviewed 60-something years worth of literature around cheatgrass control and tried to establish patterns of what had been done and what hadn't. And really the only two things that led to longer than 1 year worth of control at that point in time, and we looked at grazing, mechanical, cultural, like all the, the whole list of things that you can do, were herbicides and herbicide integrated with revegetation. And so from that, we probably need to update that again. That was in 2013 before the advent of indaziflam. But so that sort of pushed a lot of the consistency at large scales sort of steers towards herbicide. And I think all of us looking around the room have done other. We've looked at prescribed fire. We've grazed it every time of year with just about every animal you can shake a stick at. And it seems like these annuals specifically, if there's any soil moisture left, they just stop growing and they produce seed. And so, we've grazed in the spring, we've grazed in the fall, we've grazed in the spring and fall, we've grazed with sheep and cows and whatever. And they just are very resilient to heavy grazing use. There is some data coming from Nevada now that winter grazing that actually limits the litter component, because there's an interesting litter dynamic with these grasses. That may lead to a slow decline in their populations, but direct grazing impacts rather than indirect grazing impacts don't seem to be as important. Great question. I think we would all, well, maybe not all of us. I think many of us would be very happy if we never had to spray herbicides again and we could do that. But right now, the preponderance of information is such that herbicides are the best tool that we have. Great question.
And it's not without trying. There's been work with weed suppressive bacteria, but it hasn't demonstrated that it can be used operationally and work. There's been work with kind of proprietary fertilizer components, which at best may work in very small areas. So yeah, it's not without trying. A lot of other options. Yeah.
Question. If we look ecologically at the North American prairie, and the shrubs have got bare ground, and that's the vacant niche that the invasives are occupying. Why aren't there annual native American species occupying that niche? Or is there something that the sagebrushes or that community is doing that is protecting their habitat from native annual grasses?
Yeah, no, that is an excellent question. So I'll just repeat the question, and I think Tim wants to answer it. But so basically, if our native system has bare ground in it between the perennials, why is there no native plant filling that niche?
Yeah, so we do have a few annual natives, and then we have some perennials that act almost like they're annuals. So Sandberg bluegrass is one that increases quite a bit when there's disturbance. We do have an annual in our wetter areas next to where we have ephemeral watercourses, and it's an annual. It's called Dischampsia danthenoides. And then there are a number of forbs that are annuals. I think the main reason is that in the West, historically there was a biological soil crust, and so in the drier areas that was made up of bacteria and algae and maybe some fungi, but it was basically almost a sealing of that soil surface, and so you didn't have an opportunity for a lot of annuals to impact that. And then when you get into the wetter areas, then there's lichen and moss in addition to those that would cover that ground surface, and that would reduce the number of plant species that would be found in those interspaces. And those systems quite often didn't evolve with a tremendous amount of grazing, and so when we saw westward movement and an increase of utilization of cattle on these rangelands, a lot of that biological soil crust was broken up. And so we really don't, there are places where we still have it, but it's less likely. And there are instances, a BLM colleague of mine that's very much into biological soil crusts, he says where he has them, he sees a decline in cheatgrass.
Brian wants to take a crack at this as well.
I'm gonna move us further east too. So we move out of the sagebrush grasslands into the northern mixed prairie where we do a bunch of our work. More rhizomatous grasses, longer history of grazing, more growing season precipitation, a lot less bare ground. Soil crusts were historically not an issue. And because of this, for years and years, the Great Basin thinking prevailed when it came to invasive grass issues, annual grass issues. And they said, all that stuff east of the Continental Divide, the more true prairie, is immune to invasive annual grasses. And I think that was largely informed by people who had never been to that part of the country, because we have tremendous invasive annual grass issues. And so that discrete, apparent niche overlap that should not be present in the sagebrush grassland system, it doesn't make sense in the mixed grass prairie, and we have tremendous invasive annual grasses issues there too. So I think it's largely a temporal mismatch in that. So our winter annuals green up and take advantage of that snow melt and that early moisture before we start. A lot of our perennials really even get to get started for the year. It's a great question. The thing that scares me about your question is that if it truly is a vacant niche that can continue to be invaded, is no matter what we do, they're going to keep coming back. And that's terrifying, but maybe that's why we are where we are. Great question. I was just giving a little different perspective.
But I was just say, like, in Australian context too, we see very similar situations now. Like semi-arid areas is not uncommon. You might have perennial grasses, and then during your wet period, you might have a series of forbs come up. But for most of the year, we have very few annuals in those sort of bare areas, and it just seems to be an ecological process we've come through.
So for the recording, Dr. Ingram says that they see very similar patterns in Australia where they have systems that inherently have a lot of bare ground that don't have an annual invasion component as necessarily that we do in the western U.S. Was that a good paraphrase? All right.
Yeah, I guess if it's back to me. Okay, any last questions? So thank you all for staying right to the very bitter end here today. I want to thank all our speakers. Everybody kept right on time, so it made my life very easy. And hope you all have, well, I guess there's still another day tomorrow, and then safe travels home. Thank you.